Okay, so this will be chapter 8. Hopefully we can knock this out a little bit quicker than the others. So what we're going to be talking about today is going to be talking about outliers a little bit and their effect upon a linear regression line. What point has high leverage and what point is going to be considered an outlier or causing change to happen. So what we want to think about is we want to think about a teeter-totter, okay? When we think about a teeter-totter, obviously we're going to have somebody over here, horrible drawing, give them arms maybe. I don't know what I've given them, but here we have person A over here, and we have person B over here. And in order to teeter-totter, they go up and down because they push off with their legs, and they have equal weight and control. However, if I slide in and let's move this person to the middle of the teeter-totter, they don't have any effect over, or actually, let's not do that. Let's take a person on this teeter-totter. If I start them at this end and they are walking on the teeter-totter, that's going to force my teeter-totter down, okay? So it's going to go up. But as they walk towards the center of the teeter-totter, it levels out. But when I stand over the middle here, I am not going to have any effect of my teeter-totter. It stays flat. And then as I walk over here, it's going to go push down. So for a point to have high leverage, okay, leverage means there's a large distance in x direction, okay? Meaning if I look at my scatter plot, my points have to be back here or my points have to be out here. Those points are going to be high leverage points, okay? Because they are going to have a vertical distance from the center. So if this is the center, these points out here have high leverage. Because they are further away, okay? Yeah, so what's the other point? We'll come back to that. All right, let's look at what we have to do here. So, is it unusual? Does it have high leverage, large residual, or both? And then the other keyword is influential point, and influential is going to change the slope of the regression line. So we're going to add that up here. That's the other word I couldn't think of. All right, so influential, I will change that to a different color. Influential changes slope of least squares regression line. So that's what we're after as far as definitions wise. I just put them up there and added that to that. So here we go. So we have to answer 4 questions for each graph. So number 1 is that point unusual? Yes. Okay, this point has an unusually high whatever and unusually high whatever in return. All right, so that's why it is unusual, okay? And we don't have any context for that. Hopefully we'll add that context when we get there, but it is high X, high Y. Okay, is it unusual? Does it have high leverage? This one, yes, it has leverage. Again, it's out here. My middle is right here. There's my point there. It has high leverage. Okay, so that was question number 1. Residual is small. All right, there's my line of regression. A small residual. Do you think that point is influential? My answer is no, because on least squares regression line. So remember, it's only going to be influential if it changes the slope of my regression line, okay? And if that point wasn't there, so I'm going to draw a blue line. If that point wasn't there, I have the same exact line essentially because that's where my data was pointed, okay? 3, if that point were removed, would the correlation become stronger or weaker, okay? And my R becomes weaker. Width provides strength, okay? The wider it is, the stronger, the more effect it has. We didn't go through the formula on how R is calculated. It has to do with the standard deviations of X and Y. And because I have a large outlier in the X direction, the standard deviation of X changes, and so therefore it has a major bearing on R, but we didn't have to get into that in this class, so we're not. Okay? Again, width provides strength, though, therefore R becomes weaker. And our last one is, would the slope increase, decrease, or stay the same? and the slope is the same. All right, so moving on to number 2. Again, number 2, yes, it has a low y given high x. Okay, and it has, now, if I draw that line in there, it's going to be something like that, but with that point there, it has going to look something like that. So that is why that point, when we get down to it, it's going to have a lot of leverage. Now, right now, it has, we're going to say it has a large residual, okay? It has high leverage. I'm going to leave, yeah, high leverage, large residual. Okay, that was question 1. Question 2. Question 2 is it influential? And our answer is yes, because slope changes. 3, again, this, and it actually becomes weaker. This point out here actually gives it some direction. If that point wasn't there, it'd be super flat and wouldn't have much direction at all. So it is going to become weaker. Okay. And number 4 is, it is the slope of the line. Again, with that point, it is going to be, grab a pointer here. Here's the line with the point. If I don't have that point, it comes up. So that means since my line went in an upward direction, okay, I will draw that in there just for note's sake. That means that it's going to, the slope of the line is going to increase. All right, so same questions over here on number C. Actually, this should have been a C. Actually, never mind. I don't know what I was doing with that 2 there. 1, okay. Is this point an outlier? Yes. Okay. It is a high y given low x. That point does have leverage. It has a big residual. I forget what questions we have to answer there, but big residual. Yes, high leverage. Okay. I've already forgotten all the questions we have to answer. Influential point? Yes. Okay. So again, with that point present, that is going to cause my regression line to go with that point. If I take that point out, my slope now, my linear regression goes there. So it is affecting the slope of my regression line. So therefore, it is an outlier. Excuse me, it is influential because slope changes. And lastly, does it become, point where removed, would the correlation become stronger or weaker? In this case, it's our first one that says stronger. Since that point didn't meet the line at all, okay, it now there's less scatter now. That point had a large residual. And if that point were removed, again, my regression line goes in an upward direction, so therefore increase. And our last point here, last one, first of all, is that point, yes. Okay, it has a low, is it an outlier? Yes. It has a low y given x. It has a large residual. However, it does not have high leverage. Because, again, if this were my teeter-totter, there would be the center of my teeter-totter, and it is right there. It has no impact on my teeter-totter whatsoever, so therefore it is no slope, no change. 3, again, my R value is going to be stronger. Again, that R value is based upon the deviations that we have. So there's very, very small deviations within that, but this has a large deviation. So therefore, if I remove deviation, my R value is going to get stronger and the slope is going to be the same. Again, because it has no impact, okay? All right, rolling through the next one. Again, we have to give some type of, so what we're trying to do is match the R value with the additional point. So again, there's 5 blue dots there, and that would have an R value of the following. So we are trying to add points to give it direction. And so basically what happens, if I added E to my line of regression, there's where the line would go, okay? Right now, because it's a 0, my line of regression, actually I'll draw this in black. My line of regression is going to shoot through there just like that. It's a perfectly flat line. There's nothing that's going to impact it. But I'm going to add one of those 5 points and see what happens, okay? But it's talking about what match each point with a new correlation. So since we're talking about new correlation, we're talking about what R value it would have, okay? That is my R value. So that means that when I add this guy out here, this one is going to be number 1, the negative 0.9. We're going to add point E to get that negative 0.9. Now, it would appear that these line up really nice, and that might be letter D because that's a super straight line. However, there's not much horizontal distance there. So that's why D was only going to generate the negative 0.4. Okay? Again, points with very little influence are going to not affect my R value whatsoever, so that's why this is going to be C. Again, my horizontal width here, that point B is still within the 5, so it's not going to have much influence at all, so that means that A gets the 0.75 out there because it has width. Okay. For women, pregnancy lasts about 9 months, so this is going to be, we're plotting life expectancy on the x-axis versus gestation in days. There we go. Again, for these data, R is 0.54, which is not not very strong relationship. So the question is, in A, if you remove the humans from this, which is going to be designated by the X, would my association become stronger or weaker? And again, my line of regression is basically here without, okay? If I add in the humans, now it's going to pull it towards the humans, so there is my line of regression, okay? But there is a large residual here, no matter which one it goes to, so therefore, if the humans were removed, this has to become stronger, okay? Wow. Okay, it had a super large residual, and again, it provided variation in the x direction, so that would be another thing there. We have where our graph is narrower. Now, the question is there justification just to remove a piece of data? Okay, now we have to look at what we are doing, 18 species of mammals. The far to the right represents humans, so everything else is elephants or other things that have or mammals. That may, but the dog does not have. Well, I guess they do have. Some animals have medical services available that will lengthen their lifespan. So we can't use when that happens. We can't use lifespan to predict their gestation period. So in this case, yes. Okay. Yes, because humans have medical services to extend the lifespan. So here's a scatter plot for the 17 non-human species. Comment on the strength of the association. Okay. So again, we're going to draw that line through there, and so now we have, it is stronger. Residual total got smaller. Okay. Again, this point, the humans over here, this was a huge residual that figured into how strong something is, and therefore it did not have that large residual anymore. So now we have a new line of best fit. It didn't tell us what our R value is, but we're asked to interpret the slope. Again, just for extra practice. Again, we're going to start here and we're going to go under, over, and down. So that's what we see. That's what we need in order, okay? So for every additional year of lifespan, my predicted response is going to be gestation, will, because that is positive, it's going to increase by 15.5 days on average. Okay. Now, it didn't say it here, but just at one point I did not make when it came to interpreting a y-intercept is sometimes y-intercepts make 0 sense, and this is going to be a case where it makes 0 sense, okay? Because this is a negative 39. And this would be if my life expectancy was 0 years, the gestation period would be negative 40 days. So A, we're not going to have a lifespan of 0 because that's not what life is. And then B is you're not going to have a negative number of days in the womb. So therefore that just can't happen. So some y-intercepts, the definition of it is just completely weird. Some species of monkeys have a life expectancy of 20 years. Estimate the gestation period of those monkeys. So again, it's asking me to estimate or predict. So we've got the life expectancy of 20 years. So if we go to that gestation period, the gestation period hat is going to equal negative 39.52 plus 15.5 times, it's the lifespan is 20 years. So we're going to drop that 20 in there. And we're going to get 270.48 days of gestation. So there we go. That wraps